This is Caitlin Meadows Cochran for EDEV 710, and in this section of our video, we're going to be discussing the sign test. The sign test is one of the non-parametric tests that we use in statistics to test the value of a hypothesized median for a sample of data. So we use either the single sample or the paired sample sign test to evaluate the value for a median that we've hypothesized based on a sample of data. To use the sign test, the first thing that you're going to do is hypothesize that value for your median. You're going to look at your population, look at the question to be answered, and hypothesize your value for the median in that population. At that point, you will then select a sample of data from the population to use in your sign test. You take each value from this sample of data and compare each value to your hypothesized median. Any value that falls above the hypothesized median on a number scale is assigned a plus or a positive sign. Any value that falls below a hypothesized median on the number scale is assigned a minus or a negative sign. And for those values that are the same as the hypothesized median for your sample of data, you assign a 0 value. Once you've given a sign or a 0 value to each piece of your sample, to each piece of data for your sample, you're going to compare the number of plus and minus signs that you have throughout your sample. And based on the number of positive and negative or plus and minus signs that you've got from your sample of data, you're going to determine what your test value is by comparing your positive and your negative column or category in your sample of data. Whichever category is smaller, that value is going to be used as the test value for your sign test. So, for example, if we have this sample of data and we have hypothesized that our median for this sample is 8, we're going to go through our sample and assign each value a plus or a minus sign based on where it falls in the number line in comparison to the number 8. So, for example, the number 10 will be assigned a positive sign. The number -7 will be assigned a negative sign, and so on and so forth throughout the sample of data. At that point, once we've assigned a positive or a negative sign to each value, we will need to compare how many numbers in this sample were assigned a positive value and how many numbers were assigned a negative value. And if you count, you see that 6 of our data values in our sample were assigned a positive sign or a plus sign, and 4 of our values were assigned a negative sign or a minus sign. So, based on the sign test, we'll use the smaller of these two numbers, which is 4, as our test value. Once you've determined your test value, then you have to decide your critical value for your sample. And for our purposes in this course, we'll use Table J, which is in Appendix C in the textbook, as our table of critical values. So, once you've determined your test value and you've determined your critical value, you have to decide whether or not your null hypothesis is accepted or rejected based on the data that you were given. And so for the specific alpha value or for the specific significance in question, your null hypothesis is going to be rejected if the test value that you have found for your sample is less than or equal to your critical value. So here's your procedure, a little bit simpler. The first thing you've got to do is state your hypothesis and identify your claim for the median of your population. Then you find your critical value, compute your test value, and compare these two numbers to make the decision about your null hypothesis, whether you're going to reject your null hypothesis or accept your null hypothesis. And then take all this information and summarize it into the results statement for your research question. So here's an example. Suppose that we have a data set with 24 different observations. So your N value is going to be equal to 24. What we want to determine is if at a significance level of 0.05, is 33 a good estimate of the median for this population? So our null hypothesis is that our median is equal to 33. So based on the procedure for our sign test, the first thing that we're going to do is go through our data and assign each value a plus or a minus symbol or that 0 value based on where each number falls in relation to 33 on a number scale. So I've gone through and done that in the table, and you see that we have 18 data points that were assigned a minus value, 5 data points that were assigned a plus value, and we did have one data point of 33, which is equal to our hypothesized median, so we assigned it a 0 value. Based on this information, we determined that our test value for this problem is 5. And based on Table J in the appendix of the textbook, we decide that the critical value for this sample of data will be 6. So when we compare these numbers, we see that for this data set, our test value is less than our critical value. Therefore, we're going to reject our null hypothesis and say that at this significance level, our median is not going to be equal to 33. Now, up until this point, we've looked at this sign test in terms of single samples. But we can also perform what's called a paired sample sign test. And in a paired sample test, we've got 2 different dependent samples of data that are taken from the same population. Typically in statistics, we call these paired sample tests before and after tests because we're looking at some effect before and after an event or a circumstance in this population. Now, for a paired sample sign test, we're still going to assign each pair of values a positive or a negative sign, but we're going to determine that sign a little bit differently. We're going to subtract an after value from the before value for each data pair in the sample to determine what symbol they receive, positive or negative. So here's an example. A statistics professor is investigating the relationship between midterm exam score and final exam score. We've got 8 students and their scores on both exams. What we're trying to determine is at our specific level of significance, which is going to be 0.10 for this problem, is there enough evidence to decide if there's a difference in midterm and final exam scores. So the first thing we do is we determine our null hypothesis. And our null hypothesis is that student grades are not different from the midterm exam to the final exam. So here you see the same data table with the same information. I've just added a row across the bottom to show you the sign for each pair of data. So for example, for student number 1, we have 75 minus 82. We subtract the after from the before, and that would give us a negative result. So our sign for that data pair is going to be a negative. We do that for each column. We do that for each pair of data in our table, and you see the result of positives and negatives. When we compare, you see that we've got 5 negative pairs of data and we have 3 positive pairs of data. So our test value for this sample is going to be 3. Again, we refer back to Table J in that appendix, and we find that for an N equals 8 population at this significance level, our critical value is equal to 1. So now we compare our test value and our critical value to decide about our null hypothesis. In this case, our test value is greater than the critical value. 3 is greater than 1. So our null hypothesis cannot be rejected. There is not enough evidence based on the data in this sample to support the claim that students' midterm grades are different from their final exam grades. In this sample, we don't have enough information to decide if how students are scoring on their midterm exam really is different from how they score on their final exam. So hopefully through this section you have learned a little bit about the single sample and the paired sample sign test in statistics.